Good evening, everybody. Welcome back. And as scheduled, we are continuing with this session. We will be connecting with you every day of the weekdays, and we'll be sharing what little we have learned over our combined years of experience as data science. And all participants would definitely know that data science is a notion which collectively the three of us probably know maybe a bottle full of information that we have. And even that we want to share it to the fullest extent that is possible. We are trying to do that. That is our objective. And the more you share, the more you learn. So by having these kind of sessions and looking at the questions being sent out in the YouTube session or people reaching out to us, we also get to know a lot, and then we share that information subsequently in the subsequent sessions that we are conducting. So as already informed to all of you, today we are going to be discussing about feature engineering. All right, so we'll start with the very fundamental. All right, rather than asking a simple question of what is feature engineering, which is probably what you would expect, I would ask a two-part question. What is feature engineering? Why do we need to do feature engineering? And I would request Sharat to please take the center stage and start off.
Thank you, Nitin. Good evening, everyone, once again, and welcome back to the channel. Hope you're learning, hope you're enjoying. And coming to the question, what is feature engineering? Now, very common point. Again, we speak about the features that we require for model building and trying to bring a solution into the the business problem. But if I take a feature basically means your column in your data set. So if I take any field or a column, I need to ensure that it is relevant in solving the business problem. When we look into the raw data, the business can give us in different forms of data. I mean, there could be ocean of data fields that are collected by the organization. We will look into only those things which are relevant. And this raw data may not be in an appropriate form for us to directly consume. For example, in my case, when I was working on this automobile prediction models where we were trying to predict the fuel efficiency of the vehicle, we had a very simple example. We had data of purchase of the vehicle. We were dealing with the second stage. So data of purchase of the vehicle was there. And we also had the date of handing over to the second stage. So date of selling. The customer is giving the car to us. Now I have these two, but this does not make really any meaningful sense when I'm trying to predict the fuel efficiency of the vehicle. So feature engineering is trying to construct a new feature which can actually be more sensible for model building. So in our case, in this case example, I was simply doing subtraction of the two fields, the current date or the sale date minus the purchase date. This gives the total duration, age of the vehicle. So this is one example of dealing with the features that we are trying to work in our model, because fuel efficiency is directly getting influenced by the age of the vehicle. But if I use the raw data, which is given, I may not be able to capture that kind of a correlation between these two fields. So that is basically to answer the question on feature engineering.
Yeah, so if you noticed, audience, I had asked two questions, and there was a reason for asking two questions, what and why, because the what and why gets answered together. If you've noticed Sharat's response, the what and why get answered. Is for that reason I had posted it that way. So Barney, can you just add a little more with your experience of why feature engineering, more to do with why feature engineering, of course, what we've understood in your experience.
Sure, absolutely, Nitin. So feature engineering as such includes a lot of things. It is an amalgam of feature understanding. That means understanding the columns or the variables that you have. It includes feature cleansing, wherein you try to clean the features. And we spoke extensively about that when it came to our data cleansing aspects or data pre-processing. Then we have something called as feature scaling. Feature scaling means if you have two variables of different scales, then you do normalization or standardization. If you have outliers, if you're retaining them, you do robust scaling, etc. Feature engineering also includes feature construction. I'll come to that in a moment. And we have feature selection, feature transformation. All these are part of your feature engineering aspects. And within this, feature construction is something on which people have to spend significant amount of time. Because feature construction is all about coming up with new features, given the existing features which the client has given to us. And the raw data which we get from the customer is probably the first thing that one has to attack. And within our data set, we had a column called as income, which was following exponential distribution. So we had to do feature transformation, which is part of feature engineering. And we had to take a log of that to be able to effectively capture that specific feature. And, you know, in certain cases, there is not a single person. I mean, single person would not apply for the loan. You might also have co-applicants. So when you look at the total income, when you look at the applicant's income and the co-applicant's income, only when you combine, you get to know the total income. As opposed to using two columns, which is applicant's income and the co-applicant's income, when you combine these, you get something called as total income. And that total income as a variable, if you use that, then instead of using two features or two variables, you're ending up using only one. That is a total income. And on that total income, you might want to do a log of that, log of total income, so as to get more details, or so as to capture the information within that data in a much better manner. Having said that, we also have something called as feature selection, in which you might want to shortlist the laundry list of features into sizable features, which are very important. And in the due course of doing that, you have a few statistical ways of doing that. And then there are a few other techniques such as principal component analysis, which is one of the dimension reduction techniques. You might want to apply LDA, linear discriminant analysis, factor analysis. All these are used to reduce the features. Not just that, we have a few deep learning techniques when it comes to feature selection, which are most widely used and most preferred whenever you have complicated data. When you feel that, you know what, when I look at the scatter plot, there is no correlation which exists. And when I look at the probability distributions, I cannot figure out whether the data are uniformly distributed or normally distributed or whatever be it. And if you feel that through EDA, you will be able to figure out whether your data set is very complicated or not having any patterns as such, or it's very difficult for you to figure out the patterns when you do your graphical representation, to figure out the correlations and all that. Then people use techniques such as autoencoders. And prior to that, people were using RBM models, restricted Boltzmann machines, which would take your original data set of probably 100 features, and then it would compress them into probably 10 features or 20 features based on the number that you give. On similar lines, autoencoders would also take huge bunch of features and it would reduce them into less number of features. This is an automated way of reducing your features. But then the flip side of this is that you lose the interpretability. For example, if you take the income of the applicant and income of the co-applicant. When you add these two, you get total income. Here it's pretty clear on what are the features that you're working on. But the moment you resort to these kind of techniques, be it PCA or be it LDA or be it factor analysis or restricted Boltzmann machines, RBMs or autoencoders, what happens is they transform the variable to such an extent that you lose the interpretability. You don't know what are the new features which your model has come up with. And if you're using PCA or factor analysis, to some extent, probably you can figure out what are the new features to some extent, if you're lucky. But when you use RBMs or autoencoders, it is taken that it is black box. Deep learning techniques are black box, meaning the new features which would be extracted from the existing features, you will have absolutely no clue on what they are. So given this context, far too many things go into feature engineering, especially when it comes to feature selection or feature construction, because a lot of domain knowledge and a lot of complicated techniques would be used. But is it worth using them? Absolutely. And why am I saying it's absolutely worth using? Because a lot of customers expect the prediction results to happen within split second, especially when it comes to stock market kind of data, or if you're building models to predict the credit card fraud, etc., where real time you should be able to give the results. And in those kind of scenarios, it actually makes sense to compress the features using certain feature selection techniques that I've just spoken about. Yeah. Thank you so much.
Thank you, Bernie. And as always, an enthralling and detailed answer. I was for a moment afraid that you're going to, take away the kitty of questions that I have. But nevertheless, I'll get into the details, because it is a good thing we have got a great overview at a high level of what feature engineering is all about. And let's now deep dive into certain pockets within that. So my question to you, Sharath, is may seem a little trivial at this point, but nevertheless, rather than asking you once again the what of that question, my question is, what is it that you have done with reference to the various projects, not just specifically to, with reference to the fuel efficiency model that you've done, but various other projects. What are the care that you have taken for the purpose of feature selection specific to that? Definition, I think we are beyond that, but your experiences, please.
Yeah, thank you for that question. Like Mr. Bunny has already mentioned, ultimately we have to choose the right or appropriate features into our model building, and the decision, this process starts right from the step one, where we get the access to the business problem. Now, when we want to decide the features that we are going to choose, a lot of insights have to come from the subject matter experts. Unless until you understand the domain, it might not make sense for us to blindly choose some random variables and then try to build a model. So domain analytics or your domain knowledge is going to be pivotal. Then talking to your subject matter experts, you will be able to define certain variables which actually allow us to shortlist those features. This is from a subject-wise, right? Business-wise. But once we get the business-related features, once we shortlist them, we might also want to check whether the data that these columns have, these features have, actually some meaningful sense. And right, we also try to define whether the relation between the variable of interest and the features that we are taking are actually having some kind of a pattern and relationship. From that perspective, we also have to do the correlation checks, the feature important plots that Bernie was also speaking about in our last session. Using decision tree concept, we can do that. In random forest, we have feature plot as well, feature importance plot. And manual, anyways, we talked about. We also look into the forward feature selection, the AIC based techniques, which can also allow us to identify the features that we are going to shortlist, which are going to give us good results. So these are some of the points that we will have to take care of. Of course, depending on whether the values are the features that we're considering on numeric or non-numeric. Of course, when the values are numeric, we will have a lot of techniques, statistical techniques that we can use. From non-numeric perspective, of course, we will have to try and look into the relationship, and we can also use the information gain concept from the decision trees, which can help us to identify which features contain more information with respect to the variable of interest that we are trying to build the model for.
Yeah, so like I said, these are the topics which excite a data scientist, and there's something I'd like to add on with reference to feature selection. There is a simple rule of the thumb, all right? And the rule of the thumb is that the database which you get, ideally should be in such a way that the most important column or the feature is on the left extreme, and the least important column is in the right extreme. That is how it is ideally expected. So if you are receiving a database from a person or subject matter expert, or if you are even collecting the data, please identify, rank those columns 1, 2, 3, 4, which is 1, the left extreme. So if you are in short of time, that itself can be a very simple feature selection. I'll take the first and I'll take the first 20. This is again for the shortcut method. I just wanted to, share it with you. So yeah, Barney, regarding your insights with feature selection quickly, any interesting anecdote that you have?
Yeah, Nitin. So with respect to feature selection, I would say the first and foremost thing is you will have to gain sufficient domain knowledge to proceed further. As a data scientist, when you join different companies, be it Infosys or TCS or Wipro or any of the service providers, or for that case, any of the Mang companies like Meta, Amazon, Apple, etc. You might be given, for instance, if you join Amazon as a data scientist, you might be given a project in the space of procurement fraud detection. Now, you are expected to gain sufficient domain knowledge in the space of procurement management. There are a lot of research forums which are available. One classic thing that I would always recommend is to go to Google Scholar and then do a search, procurement fraud machine learning models, for instance. A few are paid, of course, you need to spend some money. Usually analytics and advanced analytics startups, as well as the mature companies, will have access to these kind of research forums. And you will have to do a quick research to understand what are the variables which are used in terms of prediction. To predict what are the various variables or features which were used. Do you have those kind of features in your model or not? It's something that you need to look at. And look at 4 or 5 different models, 4 or 5 different projects which were accomplished. Look at all the features, and the features which are used in majority of the models are probably the first set of things which you need to have in your model. When you build a model in your data set, those have to be there. Okay, this is one side of the story. And always try to normalize the data. What do I mean by normalizing the data? If you have, for example, total debt, as in the project loan default prediction model, we had something called as total debt. It can be normalized only when you know what is the total income. When you divide the total debt by total income, you get a new feature, which is normalized feature. And of late, there is huge preference which is given to these kind of models wherein you normalize the features. Okay. Yep. So it's again, if the question is around which feature selection technique is better, it's something like you're asking a question on, do I need to book a cab using Rapido or using Ola or using Uber? Or it's probably a kind of question wherein which laptop is better? Should I go with Lenovo or Asus, or do I need to go with some other laptop, right? So answer would be the same always. And once in one single word, if I were to say, you need to experiment, right? Experimentation is the only answer to the questions which surround what techniques make more sense. What techniques do I need to use? Thank you.
Thank you, Bernie. Thank you. And I see that you have quickly answered one of the questions that one of our audience has posted in that thing itself. Thank you so much for that response there. So yeah, let's quickly continue. So we've
Nitin, if I may just interrupt.
yeah.
Sharad, that link that we have pertaining to the mind map, can we have someone post it on the YouTube chat here? Because there are questions. Samyukta is asking a question, so we can probably post and then people can benefit. I think it makes more sense to have our experts posted, digital marketing experts posted on a LinkedIn profile so that they may pick it from there.
Yeah. So, all right. So I have a next question here, and I'd like to, quickly, I'm going to ask this to Bernie once again, because we have worked on something and I'm expecting him to answer on those lines. So with reference to feature cleansing, because data cleansing, yes, we have done that. But with reference to feature cleansing, what is that subtle difference between the two? Could you please, explain for the benefit of our audience?
Yeah. So Nitin, it actually means the same, because when you look at the data, your data might contain your features, which are usually your input variables, and labels, which are usually your output variables, right? So you don't usually meddle with respect to feature construction, etc., when it comes to your output variable, and you usually deal with your features. And hence it's called as feature, cleansing, or dealing with your features is actually dealing with your input variables. Given that it's a supervised learning model, if it's unsupervised learning model, then both data cleansing and feature cleansing would actually mean the same.
Thank you so much. Thank you so much. So let us now quickly discuss about, why we need to do the transformation. All right, engineering, we have done doing some combinations, but what about transformation? So Sharath, could you please throw some light on the purpose of feature transformation?
Yes, yes, Nitin. So when we talk about feature transformations, the word transformation itself has, I should say, multiple meanings. One of the first and foremost meaning that we need to consider is with respect to the distribution of the data. And ideally, it should fall under the so-called normal distribution. It should not have any exceptional cases when you're trying to deal with the data. So from that perspective, in analytics, we try to manipulate the data. You can say it's like, right, on a jovial note, we cheat the data and say that, hey, we kind of change your magnitude so that you don't show that exceptional case. This is one way to look at when we talk about transformations. So this is simply like managing or altering the magnitude of the data so that we achieve the normality constraint that is required. Now coming to the feature transformation, this is of course very similar to what we're talking about. Maybe want to change the definition of the column or the feature that you have. For example, say for instance, I was working on the data with respect to automobile industry. And here I had data with respect to, let's say, weight or the fuel efficiency itself, if I talk about. It was captured in miles per, let's say, the gallon of fuel. Now, in order to make it more readable and more easy to interpret, we converted that into kilometers per liter. Right? That's a feature transformation. The entire value was kind of altered from one unit, one form of units to another form of unit. Right? So this is feature transformation in a way to explain with example.
I see, Barney, you are, I can make out from your expression, there's something you want to add with reference to with so many years of interaction, I'm able to read your expression. So what would you like to add with reference to feature transformation specifically?
Yeah. So feature transformation is all about changing the latent structure of the data. Latent means hidden structure of your data, basically. If you're given a specific variable or a feature, and if you do a log transformation or reciprocal or Box-Cox or Johnson, anything of that kind, you're changing the underlying nature of the data. Okay. And once again, there are a few techniques which can be used for both feature selection as well as feature transformation. And one such example is principal component analysis. Right. And what principal component analysis does is it will take your original features or original variables, and then it will do some math operation on that. That is exactly what feature transformation does. You apply log or exponential or reciprocal or cube root or square root or whatever you want to do. Basically, it will apply some math application on that. It will apply some formula onto the original features. And then it will ensure that it transforms the data into a new data altogether. For example, if I have two columns, and if I feel that age and income are correlated, then when I apply a principal component analysis on that, I'll get new variables altogether, which will be uncorrelated. And certain algorithms, machine learning algorithms such as linear regression, etc., expect your variables to be uncorrelated, your features to be uncorrelated. Given that, we can use certain algorithms for multiple purposes as well. Yeah, thank you, Nitin.
Thank you, Barney. So I was also doing some research some time back, and anyway, I'm sure all of you are aware about AutoML, and everything is going in the automated way. So feature engineering also is not left out. So auto feature engineering is something that is now a range, and is a rage now, and people are talking about that, and you can explore it. So one of the questions which everybody asks, where does it leave us? All right. If even feature engineering, the domain knowledge also is no longer required, where does it leave us? So interpretability, as Barney kept saying, after you have done something and when you look at the results and you're able to explain those results with reference to your knowledge as a data scientist, is still the very much of a requirement of the human being, and the human in the loop will remain. All right, whatever advances we do, the amount of what shall I say, value addition that the human being will be doing will be that much more refined and improved with all the automatic techniques that are coming forward, for which the foundation and the fundamentals have to be strong. Foundations, when I say mean median mode, we start from mean median mode. We start from fundamentals of probability, which number of interested events by total number of events. We have to be very, very strong in that to be able to stand on that foundation, to be able to make these kind of inferences. So don't chase all these big jargons, etc. We'll do this, we'll do AutoML, we'll do auto feature engineering. Go to the basics, go back to the basics, go back to the fundamentals. These things will automatically come. So on that note, if there's nothing to add, I'll just like to wrap it up. Thank you so much, audience, for consistently coming with us and joining us every day. Kind of a routine that has become. Some people are regulars. A shout out to all the regulars who are coming here. All right, I am also quickly looking at that. Please continue to watch, continue to spread the word about this initiative that we have taken, and happy learning. Thank you so much.
Thank you, everyone. Thank you.